Alright, hey everybody. So today we're going to be constructing this pattern from the Jameh mosque in Isfahan, Iran, following the constructions laid out in the Anonymous Persian Compendium. So this is what the pattern looks like that we're going to construct. Here's the pattern out in the real world, in the mosque. And here is the pattern on Folio 192 of the Anonymous Persian Compendium, and we are going to follow this translation of that text until it says the rest is easy, God willing, and then I'm going to make it up from there. So let's get started. So I am using GeoGebra Classic 5. And I'm not going to show you how to set up default settings. You can find that in another video that I will link in the comments. So as usual, we're going to start out with a couple of points. So we're going to start out with the point A equals 0, 0, and B equals 0, 1. And let me turn on labeling for my points. All right, so the first step in the Anonymous Persian Compendium says, make angle BAG 3/7 of the right angle. So right angle is 90 degrees, and you can't take 3/7 of 90 degrees evenly. So we want to think about the right angle as being pi over 2 radians instead of 90 degrees, because we can easily take 3/7 of pi over 2 and we get 3 pi over 14. So we want to construct an angle BAG with point G over here somewhere that is 3 pi over 14 degrees. So we're going to type rotate point B by 3 times pi over 14 about A, and that gives us the angle. So let's put in lines AB and AB prime, and I don't need point B prime anymore, so I'm going to hide it. And then we need a way to find this point G over here. So I'm going to use my perpendicular line tool, and I'm going to construct a line through point B that's perpendicular to AB with my perpendicular line tool. Now I'm going to use my intersect tool to find that point G. So we're going to be renaming some things as we go along. So I'm just right clicking on this point and renaming it G, just so we match the translation. So then next it says cut off BE equal to AD. So E is going to be a point over here, and we want BE to be equal to AD. So, oh, sorry, next it says bisect line AG at point D. We need to construct D first, obviously. So bisect AG at point D. So we want the midpoint of AG, and we're going to call this D. So I'm going to rename this D. Here we go. So I want BE equal to AD. Well, AD is the same as BD. So the easiest way to get this is to put in a circle BD, and now we can put point E here with the intersect tool. I hope you got that. All right, so then we want to draw a line EZ parallel to AG. So I'm going to grab my parallel line tool, and I'm going to put a line through E parallel to AG. And I'm going to call this point over here Z. So next we want to draw a line TI parallel to BE. Well, we have to construct point T first, and the translation doesn't tell us how to do that, but it happens to be the midpoint. So there's a lot of stuff in this translation that we kind of have to just figure out. So let's rename this point T. All right, so TI parallel to BE. So parallel line through T, parallel to BE. And we can't put in I yet because we don't quite know where it is. But then it tells us to do a few things. Bisect TE at H. So midpoint again. So let's call this H. And then TI is equal to TH. So let's put in a circle TH. And now we can find point I right here. Okay, so then it says extend line EI until it intersects AB at point K. So let's draw in EI. Zoom in a little bit here. And we want to call this point K. All right. Then it says draw KL parallel to BE. So we want to construct a line through K parallel to BE. Okay, cool. And then we want to find this intersection point L. So L is right here. From center Z, inscribe arc KMN such that it intersects line EZ at point M and the arc KM becomes equal to the arc MN. Okay, so we've got a little bit of work here. So I'm going to construct a circle centered at Z through point K to find this point M right here. And then I want to reflect this line AB over this one so that I can find point N right here. I could have also just reflected K over that line to get N. Now, let's see. The arc KM becomes equal to the arc MN. We've got that. Extend LN until point S is obtained on the line AF. All right, so we want a perpendicular line, sorry, not a perpendicular bisector, through N, perpendicular here. And what we want is a point S down here. So I need to construct a line through A, perpendicular here, so that I can find this point S. Then this becomes the center of the circle that circumscribes the heptagon, and the rest of the construction should be easy. God may he be exalted willing. Cool. So the rest is kind of up to us. So let's put in the circle here. So this is the circle that's going to contain the heptagon. And next I'm going to put in an angle. Nope, I want this point. I'm going to hide the label. So I'm not going to show any labels from here because the rest of it only a couple more points in the construction online, not online, in the compendium are labeled. So what I'm going to do next is put in this angle bisector here. And where that angle bisector hits this side, oh, I meant no new objects, not all new objects. This point is labeled O. And there are a couple of notes here. It says, alternatively, angle ELN is constructed equal to angle ELK. Okay, that doesn't help. The center is taken on line LNS. Alternatively, EO is cut off equal to EL. Okay, we could have used that to find point O, so that O becomes the center of the heptagon. All right, so this is going to be another heptagon. And then OS becomes parallel to GA and equal to GA. And again, point S becomes the center of the other heptagon, and also GO equals AS. Okay, God knows best. So that is the entire translation, but we're going to do our own thing from here, because we followed the beginning up to here, so we're not going to follow the alternate construction. So I've got point O, and then I'm going to construct a circle OG so that I can find this point C over here. So this is point C. And then is that what I want? Hang on. Yeah, so I want next to be able to construct my final corner of my rectangle that this pattern is going to live in. And so this is going to be point F down here. And then I want to find the center of this pattern. So that OS divides this thing in half in kind of a strange way. But if I grab my perpendicular bisector tool and put in a perpendicular bisector between S and O, I actually get the center of this rectangle. Cool. So then next thing I want to do is I'm going to put in my heptagon. So to do that, I'm going to put in this point right here, and then I'm going to reflect that point here. So these are 4 vertices of the heptagon, and I'm going to get the rest of them by reflecting. So first, let me put in a perpendicular line that's going to be useful. And then I want to reflect these 3 points. I'm holding Control and clicking to select all of them. Let me hide that label. And I'm going to use my polygon tool to put in this heptagon. Cool. So this is a perfect 7-sided polygon. Not constructible with a ruler and compass. They would have used a set square to find that 3/7 of a right angle back in the day, because they didn't have GeoGebra. All right, so then I'm going to put in a couple of lines. So I'm going to put in this line and this line. So I'm using the sides of the heptagon to put in those 2 lines. And then I'm going to put in segment LS, and I want to make that red. So I'm constructing this just like the Anonymous Persian Compendium. And then I'm going to do a lot of reflecting about this center point. So I'm going to reflect point L over that center point, and I'm going to put in this segment. And then I want to reflect point K over this, and I'm going to put in LK and L prime K prime, and I'm going to make both of these. I'm holding control and clicking and make both of those red. And then I want to reflect point E also about that center point, and I'm going to put in this segment and this segment, and I'm going to make those both red. Then I'm going to make a line that is parallel to the side of my heptagon through point E prime. So that's this line that I just put in here. And then I want the intersection of that here. And I'm going to reflect this over OS. So those 2 points will become vertices of a polygon. Then I want a couple of intersection points. So I want this intersection point and this intersection point. And then I want to reflect this point over here, and I want this intersection so that I can complete this polygon. And let's make our heptagon blue. So we have alternating blue and brown shapes. So I've got 2 of my polygons now. I'm going to put in this line right here, and I want to reflect that line over this one. So notice that comes close to G but not through G. And I want where that intersects here. And that allows me to put in this polygon. And I'm going to make that one blue. I want to reflect this point over the center. And then I want to reflect, let's see which 2 points, these 2 points about the center. And let's see if I can get this polygon in. There we go. So make that one blue. And then I'm going to construct a line along the edge of this polygon. Notice that also goes through this point. And I'm going to construct this line. And then I'm going to construct the reflection of this point over this line to complete this polygon and this polygon. I'm going to make this one blue. And then I'm almost finished with this center polygon. I need to do some reflecting about a point. So I need to reflect this point, and I need this point over here and this point right here. So I'll use reflect about line to reflect these 2 points over that line. And now we can put in this central polygon. We're getting there. All right, so then I know I'm going to have another heptagon over here. So I'm going to put in this circle, and I'm going to do some reflecting. So I'm going to reflect this point over here. I'm going to reflect this point over here, and I'm going to put in the midpoint between those 2 points. And I'm just going to put in half of this heptagon at the top. And then I need to complete these polygons. So I'm going to reflect this point over here. So that allows me to put in this polygon. I'm just missing this point for this polygon. So I'm going to get that from over here. So that's the equivalent of that point. So I'm going to put in this polygon. I'm going to make it blue. And then finally, I can put in this corner polygon. And then we can hide our lines. We can hide our points. We can hide our conics. And we're left with just this rectangle. And I could have just put in a half heptagon here, but I did want to show you that we got that perfectly regular heptagon. And then if you want to expand the pattern, just reflect about those lines that formed the edges of that rectangle. And there you have it. All right, hope you enjoyed it. For more tutorials like this, please subscribe to my Patreon. It's Math the Artiste. See ya.